Good afternoon. This is Professor Gandhi and also Professor Marquez. We are doing the cooling curve today. Why we are doing the cooling curve? To determine the melting points of a sample and to study the effect of impurities on melting points. We are going to use lauric acid today as a solvent. And why we are using lauric acid? First of all, it is cheap and it has a low tendency of supercooling. It has also a low melting point, that the melting points of lauric acid is about 43 degrees Celsius. So the thermometer, which we have here, can take it and measure that temperature. We are going to use the capillary method by heating the sample and record the melting points, and then we'll draw the curve. What is the advantage of the cooling curve? It is to determine the amount of impurities and determine the depression caused by the impurities. The amount of depression is determined by the number of moles, not by the properties of the particles used. We have the cooling curves on the board back there. So if Dr. Marquez wanna talk about the cooling curve, and we are doing it for lauric acid again.
Hello, class again. As Professor Gandhi had talked about the cooling curve, we're going to do the cooling curve. This is part of what we call colligative properties. The boiling point, freezing point, osmotic pressure, they're all part of the colligative property. So what happened with this impurity that Professor Gandhi is talking about? If you have a pure solution and you add a non-volatile solute, there will be an elevation of boiling point and depression and freezing point. You recall that in the East Coast, when it snows, they throw salt on the road at night. Why? Because the temp would dip down at night, probably to -8, -9, something like that. However, if you throw salt, then it takes -15 for the ice to become, so the slushy snow to become ice. We call it black ice. Many accidents happen on that when you have black ice. You break the car, boom, it will just break down. So also in your car we have antifreeze. Antifreeze, why it's used? Because in the summertime the water will boil at higher temp, so therefore prevent boiling water from your car. And also in the winter time the freezing point will come down, therefore it doesn't freeze that at slow temp. All right, so here is the curve. It's very simple. This is the theory about it. The red line, that's a pure water, and the blue, that's after adding salt to it. That is water with salt. Now you can see here in the high, this is the pure boiling point of the water, and when you add the solute, it's going to increase to this much. That's the delta TB, the difference in boiling point increasing. So therefore there is an elevation of boiling point. The same token, there will be also depression and freezing point. This is the pure water, this is water with salt, and there is a depression in freezing point. So therefore, as you recall, there is depression of freezing point and elevation of boiling point. All right. The equation is very easy to remember. Delta TF is equal KF times M. Delta TF is the temp in degrees C. KF is the freezing point depression constant. That's for the solvent. And lauric acid in today's experiment is the solvent. The K is equal 4.40 degrees C, kilogram per mole. Molality M is molality, so don't confuse molality with molarity. It's very similar. However, the molality is number of moles of solute per volume of solvent in kilogram. Recall the molarity is number of moles of solute per volume of the solution volume, total solution, including the solute in liter. That's the molarity. That's the difference between molarity and molarity. All right? It's a new term for you, I'm sure. The molarity is a new thing. All right? As you can see, delta TF, that's for freezing, is equal to KF times M molarity. You can do the same equation. Delta TB for boiling is equal to KB, that's also the constant for the boiling of solute, times the M, the molality. All right? So now we're going to proceed with the experiment. Professor Gandhi is going to do the experiment, and it's going to be the delta F, which is the freezing. So we're going to have lauric acid as solvent and benzoic acid as solute. And we're going to find out what is the depression in freezing point.
All right, you have a table here in your textbook. You want to take a picture of this table? This is the one you are going to fill as a result of your experiment. So what I did here, we're doing part A, the mass of the test tube. So I got the mass of the test tube, I reported here. The mass of test tube alone is 24.42 gram. Dr. Marcus, if you want to write that. Mass 24.4 gram, test tube only. Test tube plus lauric acid, I added about 4 gram of lauric acid. So the test tube and lauric acid, it came out to be 28.51 grams. And then the mass of lauric acid by itself, we subtract both from each other. Lauric acid is 4.09 gram of lauric acid. So the lauric acid inside the test tube is about 4.1 gram lauric acid. Connected the test tube here. We put about 200 milliliter of water, and we're going to insert the thermometer inside the test tube. And you can stir the sample with the thermometer, but be careful not to break the thermometer. All right, I'm going to turn the Bunsen burner on. Okay, we're going to heat. All right. We are going to heat the water to about 50 degrees C. So we have to look at the temperature when it is around 50 degrees. We're going to stop. And we shake slowly inside. We are going to take the temperature every 0.5, but when it reaches, when the water is 50 degrees C. Now the water is about 25 on the thermometer. Okay. It's almost 28. It's about 40 degrees here now. Sorry, it's 30 degrees here. We are going to use later on benzoic acid as a solute, the solid benzoic acid. I'm going to add it, and it's about 0.4 gram of benzoic acid.
Tell me the result. I'll write it down over there. Hello? I'll write down the. You tell me.
Oh, you will?
I'll write it down.
Okay. Start to kind of melt. And the temperature, if you can see now, it's about 40 degree, 42. It's going to about 43 degree. I can see it is dissolving. It's about now 48 degree. I have to get ready to put it up the tube, raise it up. It is 50 degree. Okay, now every, it's 50 degrees C. This one is kind of loose. Get me the worst one at it. Okay. All right, now we are going to measure every half a minute the temperature. Now it is going, the first half minute, it is 54 degrees C.
64?
Yes.
54.
54, 5-4.
54.
All right?
54. Uh-huh.
My watch doesn't have a second.
There's
okay?
a watch right there. You don't have a
Oh,
second.
okay.
It's easy.
You have yours.
Halfway.
Okay, now it is 53. Fifty,
55, 50.
50, 50. This is bad one. Doesn't, I tried. It's moving this, oh, it's now. Okay, 50, 48. 46. 45. 44.
44, right?
Correct. 43.
43.
Yes. 42. 42.
Another 42?
Yes.
Or did it change?
Didn't change it that much.
You're gonna have plateau sometimes.
43.
43.
Yes.
It went up.
Went up one. I don't know
It
why.
went up.
Again, 43. $43. Let's check it. $43.
Oh, where did she back up?
$43. $43. $43.
42.
3.
Sorry.
$42.
42.
Yes. $42. 42. Forty-two. 42. 42. 42.
'Plateaued, I think. At 43 some and then 42.
42.
I think that's going to be the plateau, 42.
Forty-two. 42.
Again, 42.
42.
'Plateaued at 42.
Supposed to drop little bit than that when a sample solidified,
Yeah, I think
but it is still kind of
did
warm.
solidify it? Oh, okay. It did solidify. All right.
Yeah, because not all of it's solid yet, that's why.
Let me guess, 42?
Yes, this 42.
All right, so you're gonna do now the benzoic acid, the impurities.
All right. So you can see that the temperature was steady for a period of time, no changes. Now what we are going to do, We are going to wait, I already weighed 0.4 gram of benzoic acid, and we're going to add it to the test tube, which has lauric acid. Okay. It's kind of solidify on the side here. All right.
You need some of that there? Okay?
Lauric acid and heat.
Yeah. You don't need
So
some
we put
of that.
this back, and we'll put the benzoic acid now. This is right the amount of benzoic acid. I think I put it somewhere here. Benzoic acid is 0.41 grams. 0.41 grams. Okay. Maybe you can add some water in here to be sure that the sample all in water. We are heating it, right?
Same thing.
Huh?
I'm gonna make the graph.
You have the other graph, right?
Yeah. 50 degrees.
Okay. Okay, now with benzoic acid, here is the table for when we add benzoic acid. This is the table you are using. We are repeating the same thing we did before. So we're going to heat it again to 50 degrees C as we did before. And then we are going to raise the test tube and do the same thing. Now the temperature is 45. Stir carefully so you are not going to break the thermometer. start to dissolve. And the temperature is 48, about 48 now. Okay, Dr. Marcus, at 0 degree it is 50. We're going to raise it up.
We starting? Okay. 0,
0.
at 0 time, what's the temp?
0 time is 50 degrees C.
50?
50.